Okay, so moving on to problem 3, we're given a definition that a fruit is a leaf node that has a parent but no siblings. That is, its parent has no other children, and we're also told that we should use the tree class as appears in the midterm 2 study guide, as well as this new function that they've defined for us that returns whether tree T has exactly one child that is a fruit, so a leaf with no siblings. So basically, it seems like this fruited branch will return true if we have some kind of tree that looks like this. So it has a root, and then it has one child, which is a fruit, which is a leaf, and it has no other children, meaning that the leaf is also a fruit. Okay. So in problem A, we're told to implement some fruit labels, which takes in a tree instance T and returns the sum of the labels of the fruits in T. Cool. So based on this kind of skeleton, as well as the fact that we're working over trees, we should immediately think of recursion. So you kind of have this if-else structure, which usually signifies base case and recursive case. And it seems like our base case is calling the fruited branch and then returning something. So let's figure out what our base case is asking for. So if we go into our base case, if fruited branch returns true, that means our T looks something like this, right? It has a root and then some leaf value, but we know that it must have no other children because we know that this leaf is actually also a fruit. And by that problem, or by the problem, we know that the root has no other children, right? So we know if the root only has one leaf, which is a fruit, in order to return the sum of the labels of the fruits in T, well, it's just going to be the value of that leaf. So what we can do to get that value is just go t.branches and index the first branch because we know our leaf/fruit is the only child of root, and then get that label. So dot label. So that should be our base case. Okay, so now let's figure out what we do in our recursive case. So we go into our recursive case when fruited branch on T returns false, meaning T can no longer look like this, right? Because then we would go into our base case. So instead, T has a few different options of what it could look like. One, it could just look like a root with no children. Another option could be a root with multiple children, right? So like branch 1, branch 2. Or it could also be just a root with one child that isn't a leaf, so not leaf. Okay, so you might think that, wow, there's so many like different options of what it could be. How are we going to take into account all of them with just one else case? So now, instead of solving all of these different cases at once, I'm just going to pick one of them and try to see where we can go from there. So let's pick this middle case where T looks like a root with multiple branches. And just because this kind of looks like our typical example of our recursive case in trees, right? In class, we've worked through a lot of problems where the base case is like if T is a leaf, and then the recursive case would be if it's not a leaf, recurs through all of its branches, right? So in this case, we would need to have a for loop to recurse through all the branches, but since we are only given one line, we know we're going to have to use some sort of list comprehension here instead, because list comprehension is essentially a way to make a for loop one line. So what do we put in this list comprehension? Well, if we have this case where T looks like a root and then has branches, if we want to sum all of the labels of the fruits of T, essentially what we want to do is sum all of the labels of the fruits inside branch 1 and inside branch 2. So essentially we're calling some fruit labels recursively, right? Some fruit labels. And we're calling it on the branches of T for every B in T dot branches. Cool. Because we want to essentially recurse and add up all of the fruit labels in branch 1 and branch 2, and if we sum those together, that's all the fruit labels inside our original tree T. So after we have this list of the individual sums for each branch, we're going to want to sum them together using a sum function, and that will give us the number of fruits inside our original tree. Sorry, not the number of fruits, the sum of the labels of the fruits. Okay, so we know this is going to work for our middle case that we chose, but what's going to happen if T looks something like our first case or our third case? Well, let's talk about our third case first. So if T looks like a root that just has one branch, which is not a leaf, we know that what we wrote here will still work for it. It's not really specific to how many branches T has, because we're doing the same thing for all of the B's in T dot branches. So we know the code that we wrote will actually work for this case just fine. Okay, so now we just need to worry about our first case. So what if T is just a root that has no branches? Well, we know that it's not going to be a fruited branch because it doesn't have one child, which is a leaf. So we're still going to be in our recursive case. But if we go into our recursive case, we're doing a list comprehension for all of the B and T dot branches. So if T dot branches is an empty list, we're not really going to do anything with that list comprehension. Essentially, this inner line here is just going to evaluate to an empty list. And what happens if you sum an empty list? Well, that's just some kind of thing you can try out in Python Tutor, but what you're going to get is 0. So essentially the code that we've written here works for all of these three different cases, where T is just a root with no children, where T has multiple children, and where T has just one child. So I guess what I'm trying to say is this code seems like it should work for all of the different cases. So I'm just going to write it out in our little boxes here. Some fruit labels just for completion. So yeah, that was problem 3A.